Okay, this is Mr. Bus, and I'm going to work on these last two problems. They're pretty difficult, and I don't have them previously solved, really, so this video is going to be kind of me struggling with them a little bit. So sorry if it's a little longer of a video because of that, but I'll do my best here. So this one's tricky. There's no real obvious place to start for me. I mean, you look at the HindIII, it's going to make kind of some interesting cuts. It's going to make cuts that are like close to each other because you'd have like a 3.82 and then a 0.18 section like that. So we do know that that's going to be part of it somewhere. Then I try to look and I say, okay, what about the BAM-H1? So again, the whole thing is 4.0, right? So we're dealing with the 4.0 kilobase kb plasmid. The BAM-H1 is going to make two cuts kind of like that with a 2.35 and a 1.65. And the EcoR1 is going to do like a 3 and a 1, so it's going to be like that. So two cuts for each restriction enzyme, and now we just have to kind of look at the combinations and see what's going on. So I think I'm going to work with the BAM-H1 and the EcoR1 first. I kind of like how these numbers are maybe easier to work with for me. So BAM-H1 and EcoR1. So I'll put the EcoR1 up on there first, 3 and a 1. So here's like a 3 and a 1, right? Okay, EcoR1 would be like that. And then, so that was blue. All right, I'll use red. So the BAM-H1, I'll try to do those next, are going to give me a 2.35 and a 1.65. But where, now that the EcoR1s are on the plasmid, where in relation to the EcoR1 should the BAM-H1s go? So I'm going to look kind of at these and see how those are going to end up making those. So does anything add up here? Kind of. The 1.6 and the 1.4 look like they add up to a 3. Okay. And the 0.75 and 0.25 add up to a 1. Okay. So that this 1.0 section there, I'll write that in blue. That's a 1.0 between those, and this was a 3.0 all the way around there. That 1 is going to get broken up into a 0.25 and a 0.75. So wherever I put the 0.25 is going to determine the rest of this here. So I'll put the, I'll use red. I'll put the 0.25 right there. So there's a 0.25. And then this is a 0.75, which adds up to a 1.0 for the EcoR1. So that would be a BAM-H1 cut, and I need one more BAM-H1 cut on there. All right, and I need it to be creating a 2.35 and a 1.65. So it's either going to go like over here or over here, depending on how the numbers add up. So this 3.0 section is going to get broken up. Remember, the 3.0 gets broken up into the 1.6 and the 1.4. So let's just let's put the 1.6 here. And if I do that, kind of like this, if I do that, then do these two add up to one of these two BAM-H1 numbers? So 1.6 plus 0.75 equals 2.35. Yep. So if I put the 1.6 there, and if I put the 1.4 here, okay, then does a 1.4 and a 0.25, 1.4, oops, 1.4 plus 0.25 equals 1.65. And that would be right here. So good. That's good. So far, so good. I'm going to erase my chicken scratches there a little bit. Those are the BAMH1s. Okay, wish it were that simple, but now I have to put the HindIII on there. Remember, the HindIII is going to cut somewhere and leave, they're going to cut two cuts really close to each other. I'll use purple. That. Okay, I think I got it. Took a while. I had to turn the camera off so I could think without the video recording. So, again, summary is that looking at the way that they're cut here, if the HindIII and the EcoR1 are cut, we still have this 1.0 section from the EcoR1, so that told me that it doesn't happen there. Okay. Also, some logic that we needed to be able to use is that the HindIII cuts are really close to each other. Okay. So wherever they exist really close to each other. All right, what I ended up doing, is putting them here and looking at the BAMH1 and HindIII combination. So if I do that, if I just use BAMH1 and HindIII, I end up with a 2.35 section, which would be that. Okay, the 1.6, let me just check, 1.6 plus 0.75, 2.35. So yeah, basically get that giant section that's left uncut by the enzymes. And then the section here is going to contain those three. So we need a 120, a 0.27, and a 0.18. So the 120 would be from here to here. And the 0.27 would be here to here, and the 0.18 would be there to there. So let's draw those on there. 0.27, 0.18. Okay, those are the HindIII cuts. And then we have to kind of redo this. This 1.4 is no longer a 1.4. It's 1.4 minus 0.18 and minus 0.27. So that's now a 0.95 here between those two cuts. And then if we do that, gosh, I think all the numbers are on there. I think it works out, and I think that's the solution to it. That the HindIII cuts are between this and that section there. And then you can just double check your work and say, okay, what if remember these are color coded here. Those are the purple ones. Those are the red. And those are the blue. So you can kind of look and say, okay, what if I just did the purple and the red cuts, right? And then I would have these fragments. And is that right? If I just did the purple and the red, would I have a 2.35, 1.2, 0.27, and 0.18? So let's look. Just the purple and the red, ignoring the blues. 2.35 would be, I'll use the gray here. 2.35 would be from here to here. A 1.2 would be from here to here. A 0.27 would be from there to there, and a 0.18 would be from there to there. So that would work. Okay. What about this section? If I just had the purple and the blue, would I have 1.87? If I just had the purple and the blue, where would that be? 1.87 would be that section. 1.6 plus 0.27. a 1.0. If I just had the purple and the blue, would be there. 0.95 and a 0.18. Yep, 0.95, 0.18. So that's how you can kind of check your work once you've done the logic and put things where they need to go. How about this one? 1.6, 1.4 if I just had the red and the blue. 1.6. If I just had the red and blue, 1.4. Give me that. 0.75, 0.25. Yay, it worked. All right, on to the next one. Question 6. Okay, the last question, number 6. This one actually I probably should have made 5 because this one seems easier than 5. 5 was really difficult for me. So we're only dealing with 2 enzymes, which is kind of nice. But each enzyme cuts, I think, 3 times. So like, for instance, Sal1 would make 2 cuts kind of close to each other to make a 0.25 section. That'd be that 0.25 section. And then it's going to make a cut somewhere else to make a 2.3 and a 1.8. So those would be like the Sal1s. The whole plasmid is 4.35. All right, and then for this HHAL2, for that one, it looks like the Sal1, the 230, probably gets cut into a 120 and a 110. So there would be like the 120 and the 110, for instance. Okay, now we're gonna take this 1.8 and cut it up into a 0.75, 0.7, and 0.35. Because we're gonna leave that is just that, we're gonna leave that. Okay, so, sorry, I had to turn the camera off again to think while the camera wasn't running. I think I got it though. So again, just double checking my work. The purple ones were the HHA3 and black ones were the Sal1s. So let's see, if I just made these cuts, I would have, again, here's 2.3, here's 0.25, and here's the 1.8. So add those up, that works. If I just made the purple cuts, I would have a 2.10. So the 2.10 would be if I added all those up. No, sorry. 2.10 would be if I added the 0.7 plus 0.25 plus 1.1. The 1.55 would be if I added the 1.2 and the 0.35. And then the 0.7, oops, okay. Looks like I did that wrong. That should be 0.7. 0.7 would go there. And then 0.75 would go here. Yeah, let's just do the math really quick for that. Make sure that adds up. 0.75 plus 0.25 plus 1.1 equals 2.1. Yeah, so that's where you get the 2.1 again, and the 1.55 is there, and the 0.7 is there. Good. Sorry, I just had to check my work, I guess. Oops. Okay, and then the last one, if I made both the enzyme cuts, you'd have 1.2, 1.1, 0.75, 0.7, 0.35, and 0.25, and I'd have them all there. Yay, it worked. All right, hope that was helpful.